All right, so next up we have a few different examples of solving rational equations. Remember, our first step that we want to try and do is see if we can't factor out our denominators, because that's going to help us find the LCD. So here, I notice that both of these have an x, so I can factor an x out of that. If I factor an x out of x squared, I'm left with just x. And I factor an x out of negative x, and I'm left with just negative 1. And you can double check that by doing distribution to see, hey, x times x is x squared, and x times negative 1 is negative x, so that checks out. Okay? And then my second fraction, x minus 1, there's nothing really to factor with this one. It's just x minus 1. That's all there is to it. Now, that means that our LCD needs to have the x, and it needs to have an x minus 1 from this first fraction, but then it also needs to have an x minus 1 from the second fraction. But remember, all we need are unique parts. So that one is just fine. We've got those parts. So this is our LCD, x times x minus 1. Okay, so let's make sure we take a look at our first fraction. It is going to be written out like this: 1 times x minus 1. Does it need any of these different parts from our LCD? No, it's got the x and it's got the x minus 1. So that's fine. Let's go ahead and take a look at the second fraction. 1 over x minus 1. If I put that in parentheses, we can see that it's missing the x part. So that means I need to multiply both top and bottom by x. And then we can go ahead and distribute those through. We have 1 over x times x minus 1 equals x times x minus 1. And now we can go ahead and take a look and see, okay, what are our excluded values here? The excluded values, we have what can I plug into the denominator to make it 0? So what can I plug into x times x minus 1 to make this equal to 0? Here I would say x cannot equal 0. And here I would say x cannot equal 1. If I plug in a 0 in for x, that's 0 times negative 1, and that's 0. Can't have that in the denominator. If I plug in 1 inside my parentheses, that's going to be 1 minus 1, and that's 0. And that's going to lead to a denominator that equals 0 as well. I can't have that. So if my solution is x equals 0 or 1, then I'd say nope, can't have that. That's excluded. So let's go ahead and follow the next steps. We want to now multiply everything by the common denominator. So I'm going to multiply the left side by x times x minus 1. I'm going to multiply the right side by x times x minus 1 to make those cancel out the numerator and denominator. And the only things I have left then in my numerator is 1 on the left side and x on the right side. X is already now by itself, so there's nothing left to do. But wait, we say we have to go ahead and check to see, compare this to our excluded values. X is not allowed to equal 1. That makes this invalid. Okay? So what does that mean? If the one solution that we found is actually invalid, we would say there are no solutions for this particular equation. And that's that. Okay? Let's take a look at another one. 1 over 4m squared plus m minus 5 over 4m squared equals 1 over m squared. There's nothing really to factor here with each of these, so I can go ahead and jump right into my LCD. I notice my first one is 4m squared. My second one has the exact same thing. My third one has an m squared, but it's missing that 4. So really, if it's got a 4 and an m squared, we're good. That's going to be common. I can get those really easy. So which ones do I need to fix? My first one has everything. My second one has everything. My third one just needs the 4. It's the only thing that needs. Okay? So let's go ahead and rewrite everything with the LCDs. Okay? The only thing that really changed was that fraction on the right-hand side. Now we take a look at our excluded values. What can m not equal? Well, the only thing that m cannot equal here is if I were to plug in a 0. If I have m equaling 0, that's 4 times 0 squared, and that's going to give me 0. That's undefined. So my excluded value, m cannot equal 0. Let's go on to our next step. This is where we can get rid of that denominator by multiplying the entire thing, both sides, by that denominator. That makes those go away. Okay, just left with my numerators now. 1 plus m minus 5 equals 4. We can combine like terms on this left-hand side. 1 minus 5 is a negative 4. Now we can add 4 to both sides. and we have m equals 8. Okay, and that's that. M equals 8. Was this one of our excluded values? No, so it is okay. All right, so this is the last example I'm going to do for you, and this one shows some factoring that we're going to have to do, right? So let's go ahead and try and factor as much as we can, including the numerators. Doesn't hurt to factor those. So this first one I see, hey, what is it that multiplies together to give me 15? Combines together to give me a negative 2. I can change that to be v minus 5 times v plus 3. Okay? Then we take a look at these denominators here. V squared plus 6v plus 8. What multiplies together to give me 8? 4 and 2. 4 and 2 will combine together to give me 6. So that means I can write this out as v plus 4 times v plus 2. This second fraction has the exact same denominator, so I don't need to think about it. I just need to rewrite it. And that's v plus 4 times v plus 2. Okay? So that's that so far. Now the only thing we really need to look at is, all right, well, what's our LCD going to be? From my first fraction, I see that I have a v plus 4 part, and I have a v plus 2 part. My second fraction has exactly the same thing. My third fraction has this v plus 2 part, but it's missing the v plus 4 part. So really, this is our LCD, v plus 4 times v plus 2, and that means the only thing we need here is the v plus 4 for both numerator and denominator. Now we can start to find out what our excluded values are. The only things that I can plug in for v here that are going to make this one 0, v cannot equal negative 2. And then here I would say v cannot equal negative 4. Okay? So now we can go ahead and start looking at what's my next step. Next step is to multiply everything by top and bottom. So we've got v minus 5 times v plus 3 plus 1 equals 1, and everything here is being divided by v plus 4 times v plus 2. This one is v plus 4 plus v plus 2. And I forgot about this one. I did multiply this by v plus 4. 1 times v plus 4 is v plus 4. Now I multiply everything. I'm just going to put big parentheses around the entire thing to show that I'm multiplying the entire equation because I'm tired of writing. I multiply this by v plus 4 times v plus 2. Okay, that means the v plus 4 and v plus 2 get distributed to every single fraction, and they all cancel out their denominators. So the only things I have left are v minus 5 times v plus 3 plus 1 equals v plus 4. Now this one's kind of a doozy, okay? We're going to have a little bit more work we need to do with this. I'm not going to give you too many that are this difficult, but we can still do this, okay? Let's go ahead and distribute. V times v is v squared. V times 3 is 3v. Negative 5v. Negative 15 plus 1 equals v plus 4. Let's go ahead and combine like terms. I've got a v squared. 3v minus v is negative 2v. Negative 15 plus 1 is negative 14. And then I've got v plus 4. Now, we have a quadratic trinomial on this one side, right? When this is a quadratic trinomial, I don't want to try and factor this yet. What I want to try and do is let's get one side equal to 0. So let's move everything over to the left-hand side. That means subtracting by v and by 4. Okay, we have v squared minus 3v minus 18 equals 0. Now, let's see if I can factor this. Two numbers are multiplied together to give me negative 18. I can change this to v minus 6 times v plus 3. Because negative 6 and positive 3 will combine together to give me that negative 3, and negative 6 times 3 will give me a negative 18, and that equals 0. So my two solutions here are, if I take a look at this and set this equal to 0, v minus 6 equals 0, that means that v equals a positive 6, or v equals a negative 3, and these are my two solutions. But let's go back up and just double check real quick. Are they excluded? My excluded values were v cannot equal 2 or 4, which means these two guys, they are just fine. Thanks for watching. You guys can try that last example on your own, and you will see my solution here in just a second. All right, so here's your solution for number 9. We had an LCD of x plus 1. When I multiply all that through, I actually end up with a solution of x equals negative 1, but my excluded value was actually x equals negative 1. Whenever that happens, we have no solutions. All right, thanks.